Anyway, I was driving around hitting up some hardware stores because we don't have any on the east side of Madison anymore. So I went down to McFarland and Stoughton. So when I was in Stoughton, I was like, oh, I might as well stop by the Goodwill. And sure enough, I did find a TI-83 Plus. Now, I've noticed some people in the comments saying, why doesn't Ben build anything anymore? Well, I have been building things. It's just not on YouTube. So have some patience. There will be videos in the near future where I build things, including I want to make my own calculator, a programmer's calculator with all custom buttons, so like 0 through 9, A through F for hex, dedicated binary button. And so the reason I've been buying these TI-83 Pluses is because it's really easy to interface with the screen per that one video that I made. So these are, oh, look at that awesome pi symbol someone drew in the back. These are the most common, so I figured if I'm gonna build it, if I'm gonna OSH park it, you know, might as well build 3 of them, so collecting more TI-83s. Anyway, I saw this. So obviously this is just a swipe card reader. It doesn't have the chip on the bottom, so this is probably from, oh, I don't know, probably the 90s, but it's got some really nice keys. Swipe card reader and VFD alphanumeric display. I don't know if you can see that. Let's see what's inside. All right, got the screws removed. What'd I pay for this? $3? It better be worth it. Okay, are there any date codes? 9231. Some surface mount. Looks like we got some dip 40s in here. All right. Looks like it's in 2 halves, a keyboard half and a motherboard half. And oh my gosh! It's Z-Log heaven! Oh my gosh, look! It's like it's its own single board computer. It's got everything you need. This is amazing. Oh, look at it. It's like Z-Log all the way. Oh, okay, so got a Z80 CPU. Okay, yeah, there's a date, 1992, so a little older than I originally thought, but that makes sense since it has a Z80 in it, even though they still make the Z80 today. PIO, that's a peripheral interface adapter for the Z80. So see how they each say Z80, right? But it's a Z80 peripheral interface adapter, Z80 Dart, which is a serial interface adapter. So I'm assuming this probably, well, probably, does it have a modem on it? I don't think there's enough here for a modem. However, it communicates with the external world. But I mean, it does have the serial chip. So Z-Log or Zilog, or however you pronounce it, they made a whole line of chips. So you'd have the CPU, then you'd have the peripheral interface adapter, which is probably going to the keyboard, if I had to guess. Yeah, it looks like it. See that? Yeah, it looks like it's going, the peripheral interface adapter, it looks like it's going to the keyboard. That makes sense. Wow. What else we got? Z80 CTC? Not sure what that is. This would be RAM 256 divided by 8, so that's 32K of RAM. This is going to be an EEPROM. My gosh, you could just... This is like a plug-and-play single-board computer. Yep, there's a... What is it? Okay, so 256, so 32K RAM, 32K EEPROM. There's another... Is this an EEPROM? It's got a sticker over it, but I don't think it's an EEPROM. Oh, and there's a battery on it, so it probably is keeping time. Did these things hook into the phone line? I mean, it looks like it would hook into a phone line. What are these? These probably go to the cash register. Huh. Oh, yeah, and the peripheral interface chip, it wouldn't just drive the keys, it would also drive the display. And oh, look, there's only like, look at that, there's only like a few wires going to the card reader. I have no idea how card readers work. I mean, I know it's magnetic, obviously, and they don't actually store that many characters. It's something like 64 characters, I want to say. It's basically stores your name and the card number, I believe. It's like a single board computer. It just is. Okay, I used Google to check the rest of these chips. So this Z80 CTC is a timer counter module, so it's going to be, basically be another chip that helps out the Z80. Probably used for real-time counting, timeouts, possibly frequency generation. Again, RAM, ROM. This is a real-time clock, which makes sense because there's a battery and a 32768 hertz crystal right next to it. I don't need to read the crystal. That's obviously what it would be. Then this, I looked this up. This is made by TDK. This is a single chip modem solution. So yeah. So these, the CPU is going to be accessing the modem. And then, I mean, it makes sense. I mean, this thing, I guess, probably does hook. Probably you have your phone line hooked in here. And then this talks over the phone. And then you maybe hook up your handset here. I feel like there's a lot of opto isolators here. And then also some diodes. So yeah, this thing was basically a single board computer modem system that would verify your credit card. Now, of course, if you think about it, this is just a little Z80, so probably wasn't doing anything very secure. Again, this was what? Almost 30 years ago. In the halcyon days of the Clinton administration. Wait, 39th week, the Bush administration. Well, having a system that doesn't have crypto to do the cards, that's not prudent. What is it, Mr. Carter? Mr. Bush, I'm the head of the CIA. That's why I want to talk to you about aliens. Well, what about aliens? I saw a UFO out the window of Air Force One. No, that was nothing. I can't tell you about that. But I'm the president. You do realize there's like 16 levels of top secret clearance above the president, including me. I'm George Bush, the head of the CIA. It wouldn't be prudent. And like 12 years later, now I'm the president. Hey, look, a UFO. Oh no, now I can't find out anything about UFOs. Oh well, my son maybe will when he's president. This is quite the find. It'd be funny if you make like a single line, single board computer. I'm guessing that the serial chip, the DART, probably is communicating with the cash register equipment over these ports. As far as the modem, modem is serial, but the modem is probably mapped to the I/O or as a port to the Z80. So the Z80 would just send data directly to this, via 8 bits, and then it would communicate with the servers wherever they would have been back then. Yeah, it's like a really thin client. I just love it. Look, what, four Zilog chips or Zlog or whoever, Zlog, amazing. I want to power this up, but I also don't want to destroy it. Verifone Tranz 330. It's probably 12 volts. I actually found the owner's manual for this thing online, the Verifone Tranz 330. One of these goes to the wall and the one of them goes to your phone, so it passes through. These are just serial RS-232 jacks. It doesn't say how much power it takes. I'm assuming it's center positive. Yeah, it's going through a mess of diodes. No, that's probably why I can't get a direct connection to beep it out. All right, let's go for some ohms then. All right, that's a known ground on this ROM. I'm guessing this is ground. But every so often they make one of these where the barrel is power and the center is ground. Usually they do that for battery controlled applications, so you have like a cheap disconnect. Oh look, I happen to have one of these that doesn't fit right here. I cannot believe I do not have any jacks that fit this. Whatever. Oh man, that's kind of hard to aim. So you gotta connect that card edge connector to that one. Well, I'm not card edge connector, board to board connector, but there's really, I guess you just gotta use faith. That's too small even for the computer to hit. It's not too small. Just another sad love song racking my brain like crazy. And I won't let go, be it fast or slow. It doesn't let go or save me. Is that what the lyrics are? I don't know. Don't blow up. Programming error 0. Where have I been for 29 years? I feel strange. Please let me die. No, I have brought you back to life to serve a new purpose. I don't even know how to spell programming. Where are my testicles, Summer? Well, I mean, the VFD works. I mean, it must work. Programming error. Wow, the speaker's really quiet. Clear is trying to do something. Oh, what do I care? I don't want to use this thing as a card reader anyway. Maybe I could become a card scammer. It's like if someone saw this in front of a modern gas pump, they would laugh. Well, CPU works. The VFD works to drive the display. And since the PIO would just be a dumb peripheral interface device, that means the Z80 itself is having to do the matrixing for the keyboard. And this, which means a lot of time is being spent just updating all the letters. But look at all those characters. Like this is like a speak and spell, but you could spell words that have more than 8 letters in them. Like constabulary. Maybe I could make the world's most annoying speak and spell, where you have to spell the words using type 9 or whatever it's called. You know, like how we used to do text messages 20 years ago. Next spell, disenfranchisementalism. 10 minutes later, wrong. Try again. My niece found out that I have a keyboard, so she's been playing it all afternoon. Sounds like right now she's trying to play Careless Whispers. So hopefully I don't get a copyright strike. How's that song go? How I'm never gonna dance again. Can't you see I've got no rhythm? I'm trying to. You know what? When it comes to songs like that, I much prefer Baker Street. That's the one that goes dun 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 dun, woo, dun 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 dun, woo, dun 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 dun. Going down on Baker Street, feeling light in your head and light on your feet, and down the day is bound and passing away. You know someday you're gonna be happy, but you're trying now. Wow, Bear Copper. I'm surprised it didn't corrode. Now, it looks like there's a driver chip. Probably a high voltage driver chip. I do see we have, there's a crack in that choke. Yeah, so you might be able to interface this with TTL signals and then it drives this directly. But so we noticed there was no outgassing. It appears to work perfectly fine. Yeah, I'm guessing there's an 8-bit interface to this, which drives this, which would make, it looks like, all those things are going directly to it. I'm guessing, what is these? These are 14 segments, I believe, alphanumeric. Here, let's zoom in. It'll be a 14-segment alphanumeric. So you don't drive all the pins. You basically control. You control the 14 segments, and then you just turn them on one by one. So you go brr, 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 right. So you don't actually need, however many characters is this? Probably like 16. You don't need 16 by 14. You need 16 plus 14. Yeah, let's just look it up. I'm going home to have sex with my wife. My man! I'm sorry. Yeah, so this is a 14 segment by 16 digit display driver. So it does exactly what I thought it did. You'd have to see how these are memory mapped, right? But if you knew that, you could basically put basic. You could put like basic on the ROM at the upper 32K of RAM, and then have like your character terminals. You could output the characters, input them as well to this device. You just have to basically look at this. Well, there's no schematic. You'd have to reverse engineer it and figure out what port it's accessing. Oh, you can hear the air conditioner in the background. That's 0 production value. Okay, I looked it up. This has a serial input. Data, input of display data, control data, input from MSB, most significant bit. Then there's a shift clock of shift register, shifts data at the falling edge of shift clock. So, yeah, there's probably like a command byte, and then you just shift in the bits, and then this thing displays them. I mean, we could probably hook this up to a separate power supply and drive it with an Arduino without too much effort. 21. So obviously they're having to power the VFD with a higher voltage, but I think it's being generated on this board. I'm testing the connection between the boards. I'm seeing a lot of 5-volt. Of course, there's going to be matrixing going on here, and of course, serial data as well. I've disconnected the pins for the serial data going to the screen, well, rather the chip. And I've disconnected from the Z80 and connected it to this Arduino so we can hopefully try an example. So if we plug this in now, we should get nothing on the screen. Yep, because nothing's been set up because it's disconnected. Yeah, so let's write some code and we'll try to drive the screen using the Arduino. It should be pretty simple. In what is probably a shock to no one, there is actually kind of a community around this thing. I found it at bigmessofwires.com, category Tranz with a Z330, and it has the pinout of the header between the boards. All right, so let's do some defines. So I'll call this D clock. That's going to be the clock signal going up to basically the clock signal for the data. And then after that is DDAT, which is 6. And there's a power on reset. I'll just call it reset. And that's going to be 7. And reset's a little different. You just have to do a high pulse. You don't have to hold it high. Yeah, and that should be all we need. There's a built-in character set, so that's going to be a little unusual, but we can just write something to convert the ASCII automatically. Let's see. Okay. I very rarely use Arduino anymore. I mean, it's good for getting something, going pretty fast, obviously. I'm doing most of my stuff in Visual Studio, Atmel / Microchip Studio. All right, so we set those, and then we'll just do a pulse of reset. All right, and that should be everything we need. Well, at least to get it initialized. So I'm going to make a function. Now, we could actually use we could use SPI to do this because it's basically a SPI interface, but this will work. All right, so per the data sheet, which is also on the screen here, the data format's fairly simple. This is pretty much all there is to it. If the MSB is set, it is a command, and if it's not set, then you are sending the data. So I guess we could do two different things. We could do send data and send command. So we'll do send data, the data, void send command, and all this will really do is just append or not append the MSB. When we do a command to send or equals MSB, and then I guess we need another command. We'll call it shift out. Oh no, shift out apparently is a built-in command. Send data, send command. Serial shift, great. Then we'll send that to another function, which will actually send it. Void serial shift char the data. Oh, oops. Okay. And let's see, I believe it sends it MSB first. Yes, MSB is first. All right. Well, man, if we were using the serial line, this would be a lot easier. Or I'm sorry, the SPI line. All right. World's worst software shift register. Inbound. X equals 0. Actually, X equals 7. X is greater than -1. X minus minus. All right, so there's a reason I did it that way. If 1 bit shift X to the left and the data, so it'll take a 1, it'll bit shift it that many to the left, and if there's a byte present in the data, then it will pulse the signal, else it won't. But either way, it will do something. So we'll do digital write. Oh, sorry. What do we call it? The data? Oh, DDAT.
DDAT day. How about da? Cash me outside. Yeah, I just said that. Go ahead and unsubscribe. I don't care. DDAT 0. Cool. So it'll do those, and then it'll set the data, and then we'll pulse the clock, which I assume is a rising edge. I guess it doesn't really matter because the data is going to be valid on both edges. Okay. Yeah, so every time this loop runs, X will decrement, so it'll go from 765432110. Yeah, and the reason we have it's an int, so it can go negative. So the last one will be 0, and that'll still be active, and then it'll decrement, and then it will be less than, well, then it will be -1, and then this loop will abort. Char to send. Well, wait, we don't even need to do that because we've got this here. We've got the command. So we'll just say, okay, the command or equals MSB, and then we'll just send it along. And you're right, I could just send the command directly to serial shift, but I guess I'm being overly complicated. So when we do power on reset, it should default it to be 16 characters wide, which is what this is. And then it should also default it to the first position of RAM. So I'm guessing we should be able to just immediately send 16 characters and it will work, or it'll show something. Send data, and then there should be a chart here of what these glyphs look like, which is a fancy way of saying a letter. Ooh, how about this starburst thing? That's kind of cool. Oh, this is in hex. 2A. Well, fine. We'll send it in hex. 2A. All right. Let's give it a shot. What's the worst that can happen, right?
It did not work. What did I do wrong? Oh, I found the issue. I traced the power on reset pin from the header to the chip, and it's not a direct connection. So when I looked underneath the board, the power on reset pin on the header goes to a transistor. So then I guessed, what it's probably doing, since the power on reset is a high pulse and then a low pulse for this chip, it's probably taking the reset of the main system and inverting it with that transistor. So I inverted the logic, and sure enough, now it works. Beauty!
All right, now with that mystery solved, we can make a print command. So here's the 14 segment display. Font goes from that @ symbol A through undercase, so that's what, 32? Yeah, and then above that is space to, I guess, question mark? All right, so we just need to basically say if the ASCII character is above a certain range, we subtract, what would that be, 64? And if it's below a certain range, we add 20. Okay. So technically what they did was they put the alphabet in the lowest part of ASCII where the control characters usually are. All right, so we basically just do, if the character is greater than 63, then we subtract 64 from it. Yeah, this should work. Print VFD constant char string, wall string char temp equals string. Okay, so if temp is greater than 63, temp minus equals 64. And then a space would be 32. So the space and the numerals are already where they need to be. So we'll only do it if the value is above 63. And then we'll go send data, the temp. Also, I was looking at the data sheet. There are just a lot of slow timing on this. Yeah, like 50 microseconds per word. So I guess we could actually, actually, if we're going to do it, we should do it down here in this function. That way we only need to do it once. So every time we do a serial shift, we'll give it 50 microseconds to settle the data on the chip itself. Yeah, okay, so here, instead of that, we'll go print VFD, can't go lowercase, hello world. All right, let's see if it works.
And there you go. It works. What a Bobby win. Nice. We should make it change the duty cycle to make it brighter and dimmer. Okay, I'll do that next. I'll make it pulsate.
I think it'd be easier just to set some defines here. Instead of having send data and send command, Yeah, so see how we have buffer pointer control? It's a 1 in the MSB, which means it's a command, and then we got this pattern here. So we could just do a define in the program. Of course, it has to be lowercase. Define command pointer. Let's call it that. And what would that be? That would be C0? Oh, fail blog. B0. Let's see. Digit counter control. We don't need to change that. So really all we need is the pointer, which is the position on the screen, and the duty cycle. Although we really don't even need that one either because probably just have it on full bright. Let's see. So that would be E0. All right. So see how we have this command here? That's sending the duty cycle. So now we would just send the command of command cycle and then or in 10 as the value, but let's or in 31 to make it bright. And now we can get rid of the command and just have it be data. And then of course we don't need to add the byte, or I'm sorry, we don't need to add the MSB because that's in the define. So now we also have the buffer pointer control. So let's see if that's actually working too. So let's go send data, command pointer. Can you spell today, Ben? Or in, let's go 3. So it should make it print 3 to the right. So let's see if that makes a difference. Good morning, starshine. The world says hello. So my niece and I went and we bought s'more parts. Although I think it's going to be kind of warm out for s'mores. But well, okay, so the brightness worked, but why didn't the command pointer? Buffer pointer control. Oh, wait. 385 specified digit. Oh, that's weird. It also appears to be offset. See how the value of 15 is the first digit? Yeah, well, the brightness worked. Oh, wait, what's these extraneous characters here? I must have done something wrong. The X position, as in the position of X, not X position as in my younger and more impressionable days, my father gave me some advice which I've been turning over in my head ever since. Well, anyway, we see that it's offset by 1. So the first digit is 15. Second digit is 0, and the last digit is 14 when it should be, 15 if it's, counted logically. So let's just do X position, int, what position. Okay, so, well, we can't roll that over because it's only a 4-bit value. Oh, yeah, well, we said it's an int, so we'll do what position, subtract 1, and if, well, actually, we can make this, do it 1. If what position equals -1, so if it was 0, and we subtract 1 and it goes down to -1, then we change what position to be 15. Then we send the command, which would be this. We just OR that with what position. All right, so now we can change these to X position. So X position 0, X position 4. Let's see if it works.
It still is the problem where it's not updating the pointer in memory. I think I need to RTFM again. Nice. So what it's doing, the duty cycle basically says how often it refreshes it. Because remember, it's actually only drawing one at a time. So by drawing them at a faster or slower rate, it creates basically changes the persistence of vision also, not just in our eyes, but in the phosphors inside of this. So basically, by updating it faster, it makes it brighter. Okay, I did this test. I printed 16 blank characters or spaces, and then I printed sloths, and it clearly looped back around. I don't understand why the pointer part of it isn't working. I've had the song Neutron Dance stuck in my head all day. Didn't they play that in Beverly Hills Cop when he was trying to chase down the truck filled with illegal cigarettes? Oh my gosh, that was obviously the biggest problem that Detroit had back in 1984 was illegal black market cigarettes. Yeah, buffer pointer control. Why is it not working? Oh, good gravy. I was typing B in hex, but it's actually supposed to be A. Oh my gosh. Sometimes I just don't see the forest for the trees. Doing the neutron dance. What does doing the neutron dance have to do with hanging off the back of a truck? There we go. Gosh. Oh man, how many? What was that? I wasted about 8 minutes because I had B instead of A in hex. Oh my gosh. Well, you know, NASA crashes spacecraft because of bits and conversion, so why can't I? Cool, it still works. Now we can animate the text. Look at that. This is the most amazing point of sale credit card swiper the world has ever seen. It's an hour later and it's still running, which means I haven't overloaded it with extraneous bits. It's not crashing. Great, so I guess I could probably use this screen for something, although it kind of has this large circuit board attached, and I'm sure there's like probably some power inversion op amps over here, and that's providing the negative 28 volts for the screen because there's only 5 volts coming into it from the header. Still, nice being able to get it to work. Well, there you go. That was a look inside of the Tranz 330 credit card processing machine. Got a cool VFD out of it. As far as the single board computer part of it, I'll probably take that to VCF, Vintage Computer Festival Midwest 2021, and just see if, you know, maybe give it away to some kid or something, because I have enough single board computer stuff. But yeah, a lot of cool stuff in there for only $3. Well, we'll see you in the next video.